For our final lesson, let's look at a simple coordination dance that could be expressed as a line function. One arm will move on a cycle of 3 and the other only 2. Y equals 2 over 3x. One side represents the x-axis and the other the y-axis. They demonstrate increments of 3 and 2. It looks like this. Pause the video to put your creativity together and with your group create a line function dance. Y equals 3x and y equals 2x are not too difficult to start with, but maybe you're up for a challenge. Feel free to use your arms and your legs. Welcome back. Now that you've explored a way to express functions in dance, here's another way, by using inequalities. Inequalities allow me to use other functions besides simple line functions. Inequalities are a function I use to organize dancers on the stage. Let's come back to what we learned in lesson 5. Looking at the stage as a coordinate plane. If I said you could only set up dancers on y equals x, the dancers would have to set up along the diagonal line through center stage. But if I said y was greater than x, you could organize dancers anywhere above or upstage of the diagonal line. If I said y is greater than or equal to x, they could be on the diagonal line through the center and above it. Take a moment to figure out where the dancers could perform with the inequality 2x is less than y. Now, where could they perform if y is greater than or equal to x squared plus x minus 6? Graph your answer and shade in the area on the stage. I hope you have enjoyed these 6 introductory lessons. It was my hope that you would be able to see a spectrum of what I teach with dance equations, from introducing mathematical themes all the way to choreography with numbers. Connections between math and dance are endless. Once you start to think in these terms, you'll be able to create your own math-dance connections and exercises. I hope I've given you a few new tools and new tricks up your sleeve because dance is nothing to fear. It's another way to express mathematics, similar to and along with music. It can help you create a holistic classroom. It's fun to dive into math, philosophy, create your own dance number systems outside of base 10, and to get really creative in math class. Welcome to a world where numbers, dance, and calculations come alive. I'm Miranda Abbott, the creator of Dance Equations. One of the newest elements of my program is called Dancing Digits, a codified dance inspired by the Indian hand calculation technique, Chees and Bob. In my technique, the body becomes a calculator. Dancing Digits engages students in a fun and interactive way. The method integrates movement with math, which helps with cognitive development. I specifically created the exercise to help my students understand place value while enhancing their mental math skills and number sense. It challenges them with coordination and allows for a whole body learning experience. In my recent work, which you see elements of in this video, students use dancing digits to find mathematical constants and patterns. We focused on the discovery of Capricar's constant, which paired well with our place value understanding and 4-digit addition and subtraction. Capricar's constant is a unique number in mathematics. Discovered by Indian mathematician D.R. Capricar, this constant emerges from a fascinating iterative process. To explain, take any 4-digit number, rearrange its digits in descending and ascending order, and subtract the smaller number from the larger one. Repeating this process invariably leads to 6174. The ones in our feet, we do the ones. Ready? 1, 2, 3, 4. 5 is tricky. 5, gotta combine them. 6, 7, 8, and 9. Our 10s are in our arms. So nice and simple. We go 10, 20, 30, 40, 50, right? If we do 50 plus 10, we have 60, 70, 80, 90. Good. And then hundreds are in our fingertips. So we're gonna go like this. 1, 200, 300, 400, 500, 600, 700, 800, and 900. Now the fun part is the thousands. Hard, but fun, okay? Watch what we do with the thousands. Thousands go 1,000, 2,000, 3,000, 4,000, 5,000, 5,000, 6,000, 7,000, 8,000, 9,000. What does 6174 look like in dancing digits? We have 6,000, 100, 70, and 4. You got it? Okay, we're gonna take this to the park. Dancing digits works like a dial gauge. The ones, represented by my legs and feet, the tens by my arms, the 100s are on my fingers, and the thousands on my face and head. Because you do not need to keep track of previous numbers or calculations, only focusing what is on your current dial, you can quickly add or subtract. The concept of borrowing or carrying happens very organically, since you simply run out of space on your body dial. Students who learn to perform calculations quickly often find the most efficient ways of carrying or borrowing, eliminating steps. Dancing digits. Basically, I'm turning the body into a calculator so I can do basic arithmetics. I have my daughter, Arya, behind the camera with me today. She's going to call out some 2-digit numbers at random, and I'm going to calculate them very quickly with my body. Here we go.
12, 20, 60, 10, 4, 9, 120. What do you have?
I have 235.
Correct.
Correct. In my classes, we explored Capra-Carr's constant through a hands-on activity. I asked my students to find the constant by repeatedly subtracting the ascending and descending numbers. Using dancing digits, we turned this exercise into a race against students using a calculator and the students completing the calculations manually on the whiteboard. In many cases, dancing digits was faster than the calculator. Each group of 4 students begins by rolling the 10-sided die. Roll 4 times they had their first 4-digit number and would begin to find the constant. Research shows that kinesthetic learning can both boost focus, memory, and cognitive flexibility. By integrating movement, students retain the information better and enjoy the learning process. I follow Rosenshine's principles, and this is part of the varied diet I provide grade 2 classroom.
Compararlo con una medida de oro. El segundo, podemos nombrarlo una joya preciosa. Dicen que un hombre puede buscar a una mujer, pero ¿qué debe hacer la mujer mientras tanto? Todos quieren oportunidad de conectarse, de crear comunidad y continuar. A medida que el tiempo pasa, el mundo se mueve de nacimiento a muerte, a nacimiento a muerte. Alguien incluso podría decir que el patrón es predecible. ¿A dónde lleva la búsqueda y quiénes son los líderes que nos han precedido? La geometría es una parte de las matemáticas que se ocupa de cuestiones de tamaño, forma, posición relativa de las figuras y con las propiedades del espacio. De Pitágoras establece que la suma de los cuadrados de las longitudes de sus catetos es igual al cuadrado de la longitud de su hipotenusa.